Alright, so in this exercise we have a couple of multiple choice questions and they cover pretty much everything, but they are short, so let's begin with the first one. Probability questions such as what is the probability of obtaining this event and that event typically call for the multiplication rule. So the example would be, what's the probability that when you roll a die twice, that in the first one you get a 6 and in the second a 6, would be 1 over 6 times 1 over 6. So that's a multiplication rule. Probability questions such as what's the probability of obtaining either this event or that event typically call for the addition rule. So that would be an example. What's the probability that when you roll a die you get either a 1 or a 2? Probability questions such as what's the probability of obtaining this event and that event typically involve which sign? It's this one here, which looks like a flipped over U, but it technically means intersection. Probability questions such as what's the probability of obtaining this event or that event typically involve which sign? Well, that's the union sign. But the intersection sign is typically and the union sign is being read as or. A sample space consists of 80 separate events that are equally likely. What's the probability of each? Well, that's 1 over 80. A mother will be blessed with triplets. How big is the sample space? Ways of having 3 children. Okay, so there are a total of 8. 2 times 2 times 2. And the way it goes is like, so when the stork comes, the first may be a girl or a boy. Then the next one could be either a girl or a boy. Then the third one would be either a girl or a boy. So the sample space is the set of girl, 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 boy, girl, boy, girl, girl, boy, boy, so now we are done with the first one being the girl, so now we have boy, girl, girl. Then we have boy, girl, boy. Then we have boy, boy, girl. And lastly we have boy, boy, boy. So we have 1, 2, 3, 4, 5, 6, 7, 8 possible events. So there are 8 ways of having 3 children. And that is 2 raised to the 3. So a mother will be blessed with triplets. What is the probability that the mother will give birth to 2 girls and 1 boy? Okay, so 2 girls and 1 boy. That would be here. Girl, boy, girl. Here. Girl, boy, boy. No, boy, girl, girl. Boy, girl, boy. boy, boy, girl, boy, boy, boy. So it's 3 out of 8. Okay. A mother will be blessed with triplets. What's the probability that the mother will give birth first to a girl, then a boy, and then again a girl? Well, that is 1 over 2 times 1 over 2 times 1 over 2, which is 1 over 8. Okay. A mother will be blessed with triplets. How big is the probability that the mother will give birth to at least one boy? Well, that is 1 minus the probability that all are girls. So that's correct. So 7 over 8, that's correct too, because the probability that there are all girls, that's 1 over 8, 1/2 times 1/2 times 1/2. So answers A and B are correct. On a multiple choice test, each question has 4 possible answers. If you make a random guess on the first question, what's the probability that you get it correct? Well, that's obviously 1 out of 4, 1/4. Let's assume there is a die that has 12 sides. What's the probability of rolling a number less than 11? Well, that would be 10 over 12 or 5 over 6 if you round it. So I think this is pretty straightforward. Okay, so a bag contains 6 red, 3 blue, and 7 green marbles. If a marble is randomly selected from the bag, what's the probability that it's blue? So there are 3 blue over 6, 9, 16. So 3 over 16. A polling firm hired to estimate the likelihood of the passage of an upcoming referendum obtained the set of survey responses to make its estimate. The encoding system for the data is 1, 4, 2 against. If the referendum were held today, estimate the probability that it would pass. Okay, so how many numbers do we have in total? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So the 20 people were surveyed. How many said 4? That's the 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, which is the same as 6 over 10 or 60%. 14. The data set represents the income levels of the members of a country club. Estimate the probability that the randomly selected member earns at least 90,000. Okay, so first we have to estimate again the probability, the total set of events. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So how many people have at least 91,000? Well, this one, that one, this one, this one, this one, that one, this one not, but this one, that one, this one not, at least this one. Okay, so that's 14 over 20 or 7 over 10, so 70%. When using a single die, what's the probability of rolling an odd number? And of course the set is 1, 2, 3, 4, 5, 6. Odd number 1, 3, 5, so 3 over 6, 1/2. A bag contains 3 red marbles, 5 blue, and 4 green. What's the probability of choosing a red marble? So there are 3 in there, and there are a total of 3, 8, 12. So that's divided by 3, 1 over 4. The probability that a student will fail a statistics test is 0.32. Well, what's the probability that the student will pass the test? Well, that's the complement, which is 1 minus 0.32, which is 0.68. When a single card is drawn from an ordinary 52 card deck, find the probability of getting a red king. Okay, so how many red kings are there? There is the king of heart and the king of diamond. They're both red, so that's 2 over 52 or 1 over 26. Assume you want to find the probability of getting a queen or a heart from a single card drawn from an ordinary 50 card deck. Then the event queen and heart are said to be mutually not exclusive, because you can get the queen of heart. So it's either not mutually exclusive or mutually not exclusive. That's probably not mutually exclusive, that's probably the better language. Okay, so but now what's the probability of drawing a queen or a heart from a 52 card deck? So now, so this is OR, so that calls for the addition rule, and the events are not mutually exclusive. So we have to say what's the probability of queen or heart, and that's the probability of getting a queen plus the probability of a heart. But now the queen of heart is counted twice, so minus the probability of queen and heart. So what's the probability of getting a queen? There are like 4 queens in there. What's the probability of it being a heart? There are 13 hearts. And of course it's always over 52. And the probability of getting the queen of hearts, it's only 1. It's 1 over 52. So now we have 16 over 52. Or 8 over 26. Or 4 over 13. So it's C. A bag contains 15 balls numbered 1 through 5. What's the probability of selecting a ball that has an odd number and is divisible by 5? So here you got to be careful. We cannot just apply, even though you read here, you know, an and, it doesn't mean you can use the multiplication rule, because the events are not really mutually exclusive. So you could use the multiplication rule. If you said what's the probability that when you draw first the ball, and that is an odd number, then you put the ball back and then you draw another one which is divisible by 5, then you could use the probability rule. So, but here we have to look at the relevant set, and maybe let's do that in a Venn diagram. Okay, so we have 15 balls, and we are looking into odd numbers and ones that are divisible by 5. So let's make the first bubble odd, and then this one divisible by 5. Okay, odd 1, 3, and not divisible. Odd 3, not divisible by 5, but 5 is. Then 7, not divisible by 5. Then we have 9, not divisible by 5. But now we have 10, actually 10 is divisible by 5. Then 11, odd, but not divisible by 5. 12, no. 13 is odd, but not divisible by 5. 14, no. But 15. So 15 is odd, but divisible by 5. So now it is this intersection. So it is 2 over 1, 2, 3. It's 2 out of the 15. 2 out of the 15 balls. They qualify for being they qualify for being odd and divisible by 5. So it's 5 and 15 over a total of 15 balls. So 2 over 15. A spinner has regions numbered 1 through 18. What's the probability that the spinner will stop at an even number or a multiple of 3? Or that tells us we have to use the addition rule, and again the events are not mutually exclusive. So we are looking for the probability of the spinner will stop on an even number. So it's either even or a multiple of 3, or divisible of 3. Okay, so again we can have some observations where the number is even and divisible by 3, but let's first get how many even numbers are there. So it's 2, 4, 8, 2, 4, 6, 8, 10, 12, 14, 16, 18. So obviously half of them are divisible, half of them are even. Okay, how many are divisible by 3 or multiple of 3? 3, 6, 9, 12, 15, 18, so that's 6. But now how many did we count? Twice. So which one is even and a divisible by 3 or multiple of 3? So that's the 3, but that's not even. So it's the 6, the 12, and the 18. So minus 3 over 18. So it's 15, 12, 12 over 18. Or we divide by 6, 2 over 3. There are two bowls of balls. Bowl A has balls numbered 1 through 7. Okay, so there's a bowl where we have 1 to 7, and bowl B has 1 to 4. Okay, what's the probability of drawing a 7 from bowl A and a 4 from B? So those are obviously independent events because of two different bowls. So that would be 1 over 7 times 1 over 4, 1 over 28. Which of the following is concerned with a permutation? Selecting 3 students to attend a conference. No, the order doesn't matter. Selecting a lead and an understudy for a school play. Yeah, there's one is the lead, the other one is the understudy. So there's an order. Selecting 5 fruits for a suit. No. And no, so it must be B, because there the order matters. Which of the following is concerned with a combination? Trying to solve the secret code of an ATM card? No, that would be permutation. Selecting a chief, assistant chief, and a chief assistant to the assistant chief? No, that's a permutation. Cracking someone's computer password? No, that's also a permutation. So selecting 3 different flowers for a flower bouquet, because the order doesn't matter. Okay, so now let's evaluate some things. And again, permutations tell you how many ways are there of obtaining an ordered selection of R items from N. So the formula is always for combinations N. From N choose R, and the formula is N factorial over R factorial times N minus R factorial. And for permutation we write basically the same without the R. N factorial over N minus R factorial. Okay, so now we are supposed to evaluate then. Okay, maybe let's see if we can do that manually. So that should be equal to 4 factorial. That's 4 times 3 times 2 times 1 over 2 times 1. So that's the first part, times 5 times 4 times 3 times 2 times 1 over 2 times 1, 5 minus 3, 2 times 1. Okay, so there's some things that cancel out. This cancels out, this cancels out. So now we have 4 times 3 is 12 times 60. So that's 720. And this is something we still can calculate probably by hand. But in case you want to just use Excel, let me quickly show it in Excel. So the formula in Excel would be equals permut, and then it says number. So the first one is 4, and we choose 2, times, you can actually multiply that in Excel, so times the permutation. So now we have 5 and we choose 3, and then we get 720. So now let's evaluate the next one. So now we have combinations. So the first term is 4 times 3 times 2 times 1 over 2 times 1 times 2 times 1 times 5 times 4 times 3 times 2 times 1 over 3 times 2 times 1 times 2 times 1. Okay, so now this cancels out with this. So now we have 4 times 3, 12 over 2. So this becomes 6. Here, the 2 times 1 and the 3 cancel out. So now we have 20 over 2. So that's 10. 6 times 10, so we should get 60. Again, let's double check in Excel. So now we can write equals combin. Okay, 4, choose 2, times combin, 5, choose 3, and that's 60. For any subset from a set of 2 or more elements, there are always more permutations than combinations. Because you can see for the formula and permutations, we don't have that additional term that you see in the combination. Okay. The teacher's making a multiple choice quiz. She wants to give each student the same questions, but have each student's questions appear in a different order. If there are 30 students in the class, what is the least number of questions the quiz must contain? Okay, so that is obviously concerned with permutations. And so we want to make sure that we get at least 30 permutations. And so each student is getting a different test. So again, the formula for permutation is that's the permutation n r. Okay, and that is n factorial over n minus r factorial. So let's assume she would have 4 questions. Let's just assume she had 4 questions. Or let's make it even easier, 3 questions. How many ways are there to shuffle 3 questions? So now we would say how many permutations do we have? So now we would say 3. But then how many different ways do we want to choose? Well, we always choose 3 then, right? So this is n equals r. So now we would say, okay, this is 3 times 2 times 1 over 0 factorial, and 0 factorial is always 1. 0 factorial equals 1. So now if she had 3 questions and she wants to select 3 of them and order them differently, there are 6 ways to there are 6 ways to there's 6 ways to create a different exam. And every exam has a different order of the questions. So the trick here is that in this question, the denominator is always 0. So the problem basically boils down to n factorial over 1 is greater than 30. Okay, so now we just can try what happens when we get 4. So then we would get 4 times 3 times 2 times 1. So that is equal to 1224. What about 5? Well, if she has 5 questions, then the answer would be 5 factorial, 5 times 4 times 3 times 2 times 1. So that would be 120. So the answer is 5. If she has 5 questions, she can make 120 different exams where the questions are differently ordered. And again, the trick here is to realize, oh yeah, the number of questions that I have, I select all of them and then I shuffle them through. Okay, which of the following is not equivalent to 6 choose 5? So let's first see what that is. Let's evaluate it. Okay, so this is a combination. So we have n factorial over r factorial times n minus r factorial. So this is 6 times 5 times 4 times 3 times 2 times 1 over 5 times 4 times 3 times 2 times 1 times 1. So the answer is 6. Okay. So the answer is 6. So this is what we just did. 6 factorial. Okay, so this is 6. What about 6 choose 1? So 6 choose 1. Well, that is n factorial over 1 factorial times 5 factorial, which is the same. So that's also 6. What about this one? C, permutation. So 6 choose 5. So this would be n factorial over n minus r factorial. And that is 6 times 5 times 4 times 3 times 2 times 1 over 5 times 4 times 3 times 2 times 1, which is also 6. So the correct answer is 5, because 5 is not equal to 6 choose 5. Okay, 31. A coach must choose 5 starters from a team of 12. How many different ways can the coach choose the starters? Okay, so that assumes that the order doesn't really matter. So the first term is definitely correct. So from 12, choose 5. So that is definitely the correct answer, and I'll just do that quickly now in Excel. So the correct answer should be equals combine from 12, choose 5. Okay, it's 792. Okay, so the first term evaluates to 792, and that's correct. What about the second term, permute? permut from 12, choose ordered combinations, always 5. Okay, but I forgot to divide over factorial 5, so divide, and the command in Excel for factorial is fact 5. Okay, so that is also 792. So both A and B are correct because 793 is wrong. Okay, so the local family restaurant has a daily breakfast special in which the customers may choose one item from each of the following groups. How many different breakfast specials are possible? Okay, well, in this case you can choose, 3 and then 4, 3 times 4 times 1, 2, 3, 4, 5. So the answer is 3 times 4 times 5, which is 60. So that is definitely correct. So what about 5 factorial? That would be 5 times 4 times 3 times 2 times 1 over 3 times 2 times 1, so now that cancels out. That would be only 20, so only A is correct. Okay, a soccer team consists of 11 players, 1 goalkeeper, 4 defenders, 4 midfielders, and 2 strikers. Okay, so we have 1 goalkeeper, 4 defenders, 4 midfielders, 4 strikers. Okay, and on the team we have 3 goalkeepers, so we have a total of 3 here. We can choose from 6 defenders, 7 midfielders, and of course we have only 2 strikers. That was a typo here. But we can choose from 4 strikers, but on the pitch we will have only 2. Okay. So 1 goalkeeper, 4 defenders, 4 midfielders, and 2 strikers. Okay. But we can choose from 4. So now, well, first of all, the way you have to think about it, how many combinations do you have for the goalkeeper position? Well, for the goalkeeper position, so goalkeeper, you can choose 1 from 3. So that's this one. Then for the defenders, we can choose from 6, 4. Then the midfielder, we can choose from 7, also 4. And for the strikers, we can also choose from 4, 2. Okay. And now this is like, that calls for the multiplication rule, because we have to choose for the goalkeeper and the defense and the midfield and the attack. So we have to multiply that through, and of course that is something I will do in Excel. So the answer should be combine. For the goalkeeper we said choose from 3, 1. Now we can use the multiplication sign. Combine So now for the defense we can choose from 6, 4 times the midfield, combine. In the midfield we can choose from 7, 4 times the attack, combine, so choose from 4, 2. So now when I press enter we should see something which is combine 3, 1, combine 7, 4. Oh, there was a typo because we have only 6. Okay, so you gotta be careful, and I gotta be careful. You see here, so it's combine 3.1, combine 6.4, combine 7.4, combine 4.2. So that's correct. You know, 3, 1, 6, 4, 7, 4. So I had a typo. Okay, so 9,450 ways are there to set up a team. Alright, so serial numbers for a product are to be made using 3 letters, using any of the 26 letters of the alphabet, followed by 2 single-digit numbers. For example, JGR29. How many such serial numbers are possible if neither letter nor number can be repeated? Okay. So that is concerned with permutation. And the first is we have to choose 3 different letters from 26. So that would be choose from 26 all permutations of length 3 times from all the 10 digits, so 0 to 10, all combinations of 2. So now we can use Excel again to answer this one. So now we would say equals, it's actually per mod, of course, permutation, per mod. Okay, 26, choose 3 times per mod 10, 2. So they are 1,404,000. So that would be C. Okay. All right. So that is a review again of combinations and permutations, and just again, if the numbers in 34, if they could be repeated, then of course the solution would be alternatively, so if you can have a number like AAA00, then what would be the answer? Then it would be 26 times 26 times 26 times 10 times 10, or 26 cubed times 100. So in this case we would have equal 26 raised to the 3 times 10 raised to the 2, and then you would have some 300,000 more opportunities added to it. 1,757,600. Okay, so I hope that is clear. There are not too many Excel formulas that we can use here, but yeah, let's stop here And then I think in the next problem set we continue again with another problem set, which is related to base theory and decision analysis. But let's stop here and I'll see you hopefully the next video.